Welcome to this new webinar in which I will talk about a new project that I think is really worth knowing about. So I am pasting in the chat a link to the website that I am building. And as always, this website is there to stay. So you can bookmark it or trust that that page will remain, and we will add a video when it becomes available. And if you click on the slide button, that will open a slide deck. It might take a little time because Reveal.js, for some reason, always takes a little bit of time to load. So anybody who joined us a little late, pasting the webinar link, and let's get started. So I would like to talk to you about this new project of a Python notebook. It's a recent project, so it's still under active development. But at this point, I think it is mature enough that it can be reliably used, except for some cutting edge AI-related functionality that they're still tinkering with, but it's new, but well-maintained. It has solid people behind it. It's free and open source, of course, otherwise I wouldn't talk about it. And it revolutionizes the notebook idea in Python. So notebooks have become incredibly popular. They're great, but they have flaws, and I will talk about that. In Julia, people have come up with a project called Pluto.jl, where they solved those problems that the Jupyter notebooks have. And this is really inspired by the Julia notebook, but ported for Python, which is really great. So just a few little notes. Everything I am using when I talk about package installation uses UV, and I have given a webinar on UV if you want more info on that, and UV has a beautiful documentation. You do not have to use UV to install things. You can still use pip or other methods, but I will use UV everywhere because it's just so good. Also, a little note that notebooks, whether we're talking about this new type of notebook or the classic Jupyter notebook, are very good and very nice for prototyping, meaning to develop your code, to have an interactive session, make use of the fact that Python is an interpreted language with like instant feedback, and you're really welcome to use it to prototype. But they're not good at scale, and if you click here, over here, I have a link to a section in one of my courses where I explain why, and why if you want to run very large computation, you should move your code from your notebook and run a script using SBatch on the Alliance clusters. Now, also a little note that Marimo, at least at this point, is not available on the Alliance clusters. So everything I'm talking about here is to run on your machine. Again, it's a new project. Because its popularity is really growing extremely fast, I wouldn't be surprised if it gets implemented on the Alliance clusters, but at this point, it's just not the case. So you won't find anything on our wiki, it's not installed, etc. So why a new notebook? Jupyter is popular, used by a lot of people. Like, what's the point? So Jupyter, as everybody here who is familiar with it and who has tried to do some version control with Git must know very well, is really a nightmare for version control because it has this very awkward JSON format, a dot PINB, or like the Python, the Jupyter notebook extension, whatever it is, it's in fact a JSON file. And so you have your code embedded in all sorts of metadata that you don't want to version control, and it's hell. It's also hell if you try to open it in a text editor. So of course, there are tools to palliate this. There's GPText, for instance, and you can try to convert things back and forth, but it's a bit hacky. It's just a bit of a nightmare. But maybe more importantly, there are reproducibility issues with notebooks when not used well. And so this article is the result of some research that some team did. They looked at 10 million Jupyter notebooks that were published on GitHub, and they looked at a number of things, and 36% of the notebooks had not been executed from top to bottom, meaning they were just not reproducible. So the Jupyter notebook can be reproducible if run properly, if at the very end, after you've been moving cells back and forth and you've been executing cell 5 and then cell 2 and then deleted the cell that was defining an important variable and then added something, and then like if you rerun from top to bottom and you realize it doesn't work anymore and you fix it and all that, then it works. So there are ways to run a Jupyter notebook well and make it reproducible. But as this study shows, more than a third of people fail to do that because it is very easy to not have the discipline to do this and to think the notebook works. Well, in fact, it doesn't, because you've been running it in haphazard way that are absolutely not reproducible. So the main idea of Marimo is to fix that. And so even though it's a notebook, superficially, it looks somewhat similar. The interface is a bit more modern, it looks a bit nicer, it integrates with AI, but like at its core, it looks the same. But behind the scene, the philosophy, the framework is fundamentally different. Because what Marimo does is that it creates a directed acyclic graph, or a DAG, that connects all of the cells. So whenever you write a cell that defines a global variable, those are the definitions, or defs. And whenever you have some cells that make use of those variables, those are the references, or refs. And under the hood, statically, so meaning you don't have to run any of it to do this tracing, it happens statically, not at runtime, there is a graph being built that knows that cell 8 depends on a variable defined in cell 4. And that means that whenever you change any of the cell, all of the cells that depend on it get rerun automatically, and your notebook remains perfectly reproducible and perfectly up to date. There is no weird hidden state. Also, to solve the version control issue, notebooks are saved as a .py file. Like the people behind the Jupyter project, they really came up with a fantastic idea. I really don't want to sound critical to them, because they revolutionized a whole generation of data scientists by bringing this really cool idea of the notebook. It was a wonderful idea. But when you come up with a really cool idea, often the very first implementation of a novel idea is not perfect. That makes sense. So they implemented it, unfortunately, as this JSON nightmarish file format, and it just wasn't a good implementation. So the Marimo notebook solves that, because everything is a Python function. It's all in a Python file. That means that it's a script, meaning that it doesn't matter that you've been prototyping your code in a notebook. You have a script, you can run it without having to convert it or do whatever. You can run it as an app. You can open it in a text editor, and it's going to display without all this nightmare. So that's just a much more sane format. Then the interactive elements have first-class support. Jupyter allows to have interactive elements. There are widgets that work or not, depending on what you want to do, but those are states. Well, in the Marimo notebook, you can modify a variable through an interactive element. And because everything is run in Python, that updated variable can run the rest of the notebook and update all of your cells so that if a definition variable has a variable that will then be used in 5 different cells that reference it, and you have a little slider, you move the slider up, everything gets reruns, everything gets updated. You don't have to rerun everything. It's the interactive elements really have first-class support, and they're the same as assigning values to variables, basically. And then there's all sorts of cool features. And right now I'm giving a little overview to justify why this project exists, but then I will go into the details of all of that. This is just like, why is there a new notebook? But I'll explain everything later. So there are cool features. It's really integrating AI very well because it was born in the age of LLMs. Of course, Jupyter adds some LLM functionality, but it's added after the fact, so it's a bit more clunky. And it just looks more sleek because it's a very nice modern project. Now, nothing's perfect. There are always trade-offs. And so all of this sounds absolutely fantastic and amazing, but there are constraints. The fact that you have this DAG, this whole philosophy in the way this system works, that you have to follow a few little rules. They're not hard or bad, but you will have to change your coding style a little bit. Global variables have to be unique. You cannot redefine global variables in multiple cells. In-place transformation are not allowed, and mutations and attributes are not tracked. So all of this means really that you have to follow a strict functional programming style of coding. And this is actually not a bad thing because it will teach you to write better code. And if you're interested in JAX or other tools that really optimize Python and make it run much faster, they rely on this strict functional programming paradigm because this is what ultimately can be optimized and run more efficiently. So the constraints, you will have to adapt your style a bit, but I think it actually could be for the better. And then there is a computation cost. If you have this DAG, whenever you change a cell, everything reruns, everything is kept up to date. This is fantastic until you have an extremely heavy and costly notebook with big data and very heavy computations, maybe some neural network running in there. Then, of course, if each time you change a cell, you have to rerun your neural network, that would be an absolute nightmare. Luckily, you have control over what is run, what is not run, and you can disable this automatic rerunning and updating of everything. And if you do that, the reference cells, or the cell that references some definition that have been modified, are marked as stale. So you know that the notebook is not up to date, but you don't have to rerun everything all the time. So thankfully, there is a way to avoid this cost. Okay, so let's get started. So first of all, installation. And by the way, the documentation is very nice. So you can find that info in the documentation, but I will run everything with you. So this is going to be a little bit small for the time being, but bear with me. So I created a temp directory. Actually, maybe I could make this a little bit smaller. And you can see there is nothing in it. So I'm using UV. You don't have to, but I think it's the way to go. I am creating a UV project. And so now I do have a pyproject.toml file. That's the way UV works. And if I look at it, I have like some Python version, but no dependency. So the first thing that you need to do, of course, is to add in this virtual environment or UV project, Marimo. I'm passing the dev flag because it's a development tool. It's not necessary. It's just if you want to be a purist, nicer. So now I have Marimo installed in this project. I could launch Marimo. Now, Marimo has a number of dependencies that are optional, but that allow to do cool stuff. For instance, you can add a linter, and it works well with a Ruf linter. Ruf is written in Rust and developed by the same people who developed UV, so it's a great linter. You can have some LSP system. You can have some MCP server. So I will install the dependencies as well. Of course, I could have installed everything at the same time. And so now I have this UV project with Marimo and its dependencies. I'm good to start running. So how do I launch a notebook? To create a new notebook and open it, the command is Marimo edit, and then whatever name you want to give to your notebook. And I'm calling it notebook.py, but importantly, it is a Python file. Now, if you use pip to create your virtual environment, you have to activate it, of course, before you can run this command at the top here. If you use UV, you can still activate the virtual environment and then just run this command. But with UV, instead of activating the virtual environment, you can use UV run and then the command, and that allows you to have access to the virtual environment without having to activate it. So that's what I'm going to do. And so I don't have a notebook.py yet. I'm going to create it with this. And if I run this, it gives me the URL, etc., the MCP servers I have set, etc., etc. And hop, here is this notebook. So now let me move this out of the way, and let me move my notebook into a new browser window so that I can jump back and forth. Okay, it told me that it's reconnected because I moved it to a new browser window, but this is only because I moved it to a new browser window. Okay, so this is the notebook. So you can see the path over here. This is where I started my notebook, and this is the interface. Hopefully the font will be big enough. Yeah, hopefully you'll be able to see. So this is how you launch a notebook. Now, the configuration can be easily done via the graphical user interface. And at the top here, you have this little symbol, and that opens this box. And there are two types of settings. There are notebook settings here, and those will be embedded in the notebook itself and will only apply to the notebook. But then at the bottom here, there are user settings, and these are settings that will apply to every single notebook that you run. So you can change any number of things, you can explore on your own, but one thing that I suggest you edit is the package manager. So if you go into packages and data, under package management, you have a manager. And you can choose whatever you want here, but UV is my favorite, so I'm choosing UV. The reason you should do that is because Marimo allows you to automatically install Python packages when you try to run code that relies on packages that you haven't installed. And while you can change how to install things on the fly, if you set it this way, then it will already be set to the proper manager, and I think that's great. And then, because Marimo has all these cool AI pair programming capabilities, you should also set all of this up, and it's in the AI tab. And you can set everything to whatever LLM or tool you're familiar with. Code completion uses GitHub Copilot out of the box natively without needing an account. You need to enable it, but you really should, because there's no downside. You don't even need an account. Now, if you want to use an AI assistant, of course, you will need the API key of some LLM, and you will have to add that key in your config, and then you can also set some MCP server and make it like as best as possible. So all of those user settings will be saved on Mac and Linux. Different OSs might have slightly different paths. Your .config directory under the Marimo subdirectory, and it's a TOML file. So everything gets added in this TOML file. So of course you could write this TOML file manually or edit it manually, but it's much nicer, easier, and probably safer to do it via the GUI. And for information, if you have any issue during installation or setting things up, the logs are in the cache directory or a similar location for your OS. Now, as I mentioned before, the website is really excellent, and the two sections that are really important are the user guides that will walk you through every single aspect of the notebook, and the API reference if you want to tweak whatever function of whatever object in the Marimo library. Now, I personally felt that reading the user guides was the best way to learn it, but they implemented a number of tutorials, and I think those are nice, and they allow you to play with features of a notebook without having to write your own notebook. So if you want to get an overview very quickly of what can be done and play with the notebook without having to go through the entire documentation, this is actually not a bad place to start. And so let me just show you quickly how that works. So again, with UV, you need to, unless you activate the virtual environment, you want to add UV run before the command you pass. So I'm going to launch the first notebook. There's like a whole suite of them. So there's tutorial UI, tutorial SQL, but let's launch the intro one. So I launch this, it opens it in my browser. And so here is their intro notebook. As you can see, it is in the temp directory, and you can play with it, read through it. There's some instruction, etc. To kill a notebook, you can just press Ctrl+C, and it will ask you for a confirmation, and that's it. Then the page becomes stale, and you can just close the tab. Now, one cool feature is that the Vim key bindings are available, and that can be really neat if you're a Vim user. And as with Jupyter notebooks, I suspect everybody here is familiar with it. There is a command mode and an edit mode. And so you can enter the edit mode by clicking or on a cell or typing enter, and then you exit with escape or control escape. So the styling is a bit subtle. You might not be able to see it, but here I am in command mode, and here I am in edit mode. And as with Jupyter Notebooks, when you are in command mode, you can easily copy past cells, navigate through the cells, move the cells up and down, etc. Similar, same idea, basically. Then there are a whole sweep of key bindings that allows to run your rough linter, or to reformat things, or to do all sorts of things. And to see them all, you can just press Ctrl+Shift+H or Command+Shift+H if you're on a Mac, and there's a little pop-up, which is nice, so that you can get reminded easily of all the key bindings at any point. And you can also edit them, which is also quite nice. So from here, up, I can see the key bindings. I've made a bunch of edits, so those are not the default, but you can see. So it's a sleek interface. It's kind of looking funky and cool and quite modern. Now, if you're coming from Jupyter, there's a nice Marimo convert command that allows you to directly convert your notebook into the Python script that runs in Marimo. And because in Marimo, absolutely everything is written in Python, there is no IPython magics. So, but everything you have set through those magics will be preserved. It's just that it will be converted into a Python function that does the same thing. All right. So now that you've once you've gotten to that point, you've customized your thing, you've installed it, you're ready to really get started. So let's talk about the main usage. When you need a Python package, you can, of course, go to the command line and add your package, but they have this nice little feature implemented that whenever you try to run a cell that depends on the package that you haven't installed, there's a little pop-up that allows you to install it. I have run into situations where the dependencies aren't automatically, like I don't think this can handle the dependencies automatically. So if you need to install a package that then has dependencies, it will install the top package, but not all of the dependencies, or at least I ran into one such issue, but then you can always do some UV add to finish the job. The vast majority of the time it works. So for instance, let's try to import NumPy as NP. You saw the virtual environment that I created. There is no NumPy. So if I try to run this, up, missing package, NumPy is not found. But because I have set the package manager as UV, it's already selected. I could still change it here. It's going to offer the latest version, but I can choose whatever version I want. And if I click install, up, it runs UV, it installs it, and it does the right thing. Like it installs it in the UV project that you are currently running. It doesn't put it in some awkward weird place. So it's pretty smooth. Now, something that's a little bit strange at first, takes a little bit of time to get used to, is that there are two types of outputs. There are the console outputs. That's what would show up in your standard output or standard error if there's an error. So this is what you get if you print something with a print function, for instance. And that's displayed below the cell. And in app mode, I'll talk about that later, it is hidden. But then there's also the cell output. And this is, if that's true in Jupyter as well, if I define, well, let's not call A because that will conflict with other things. Let's call it new var test equals 3. So if I then run this, this works in a notebook or in a Python shell as well. In an interactive Python session, whether in a shell or in a notebook, this works. But in a script, you would not get any result if you did that. You would have to have a print function. So that's the difference between a cell output and a console output. And so they get displayed in different places by default. You can customize this and decide where you want your outputs, but this is the console output, and it gets printed below. And the cell output, as we showed over here, gets printed above. So I guess it's nice in that it makes it clear what's a console output and what's a cell output. It's just a little bit unusual at first to have things pop up at the top or at the bottom in unexpected ways. But I guess it's a nice distinction. Now, in the justification of why on a notebook, I did mention that reassignments are not possible. Like global variables must be unique across cells. So that means that even if you have a bunch of cells with a bunch of loops and you just want to use the I, like for I in whatever in those loops, even that is not allowed because you cannot reuse I across different cells. And this also, oh, yeah, I'm over here now. So if I do mu var plus equal 2, if I try to run this, I get an error message. So now what is nice is that they give you some little information with a link to the documentation on how to fix it. And so they really babysit you through the problem, but it is a problem. But don't leave this webinar quite yet. There are easy solutions. One solution is to use cell local variables. They have this syntax that variables that are prefixed with an underscore are cell local. So because they're cell locals, they will not populate the global environment. And that means that on the one hand, you cannot reuse them across cells, but on the other hand, you can reuse them in every single cell. So for instance, if I run this, this works, of course, but now if I create a new cell and I type print A again, underscore A is not defined because due to this underscore syntax, this underscore A is a variable local to this cell. It's not in my global environment, and it's not some. So do not use this syntax, of course, when you want to define global variables that you want to reuse across your notebook. But this is a way if you want to use for I in whatever 10 times in your notebook, well, then you can just put an underscore in front, and that's fine. Now, instead of using for I, you could also give it something a little bit more useful, like for character in text or whatever. But this is an easy way. An alternative method is to wrap things in function, because as I'm sure you know, whenever you have a function, everything run inside that function is not part of the global environment. It's part of the local environment of that function. And so there's no problem in reusing things across cells because we're not putting anything in the global environment. So you could also run your for I stuff in a function, and you don't have to give it a name. You can just use this syntax of underscore parenthesis to just use a function without a name, and because it has this underscore, it is cell local, so you can use the exact same syntax across multiple cells without any interference, because again, the function itself, this I here is not getting into the global environment because it's inside a function, so it remains in the local environment of the function, but the function itself does not get into the global environment either because of this prefix syntax. It remains cell local. So that's fairly easy to bypass that problem. Now, this whole idea of the DAG is that whenever you modify something, everything gets rerun so that it's always updated. Now, if you mutate elements, that will not get rerun. This is very similar to JAX. States and things that are not strictly functional programming. In JAX, it's exactly the same thing. You will not get an error message, but things do not get rerun. And so be very mindful of that, because since you're not getting any error message, you have to be aware of it and know it. So for instance, I am creating a list with 3 elements, and I am creating a new cell that shows me the length, which is 3. And now if I create yet a new cell in which I mutate my list L by appending a new element, as you can see, this cell here did not rerun. And because this is the default behavior in Jupyter, you may not notice, it may not strike you that something's not right. But of course, in this case, we're just displaying something, so it doesn't matter. But if that new list is useful, if like you've mutated a data frame by adding some columns, and this data frame is used in your analysis, if you add a new column, your analysis is not going to get updated. Of course, I could rerun that cell. Oops, sorry, I could rerun that cell. Oh, hey, why is it not rerunning it? Oh. Sorry. Yeah, so I run this, and then if I rerun this, there we go. I hate GUIs. I don't use notebooks in general, and so with my very idiosyncratic key bindings that I have in my browser, sometimes it's a bit hard to get it to work. So yeah, so if I rerun this cell, of course, I get the right result. But this automatic rerun that is at the core philosophy of the Marimo notebook doesn't happen. So this is not the way to use the Marimo notebook. Instead, if you want to modify an object, go back to the cell where you defined it and add the modification in that cell. And then if I do that, automatically the cells that depend on the new value of L will be rerun, because now the modification is in the same cell. Because remember that the DAG that is created behind the scene is not created based on individual commands. The DAG connects cells, notebook cells. So everything that happens in a cell is one node of the DAG. So if I do this, no problem at all. The problem is if the mutation happens in a different cell, so in a different node of the DAG. Or you can also, of course, create new variables. Now, of course, if you have extremely large variables, like many dimensional large arrays, this would create copies. And if you do that, remember to use the keyword del to remove objects that you might not need anymore to free some memory. Or you can also delete cells that are not defining anything that is useful later. But in this case, there's nothing we could delete, because I cannot delete the definition of L, because L2 depends on L. So in this situation here, if L were enormous, it would be better to use the approach on the left to avoid creating additional copies. So if you delete a cell, of course, this whole DAG idea works for everything. All of the cells that depend on it will rerun and will get an error message. Also, cycles are not permitted. I mean, I don't know who would want to write such a code anyway, but you don't want to have something that would make the DAG impossible, with like some kind of cross things where A depends on B, that depends on A. Like, don't try some like impossible things. And finally, attributes are not tracked. So if I defined a new class, Is this running? I think so. So I'm defining a class object, and I'm adding some value in some field attribute. So I can print the value of that attribute. Now, if I assign a new value for that attribute, such as new value, as you can see, the cells that have the initial attribute value don't get rerun. So same idea, same thing. Of course, you can, as we did before, rerun things manually, and that shows the new value, but this is not proper code for Marimo. Now, the data flow can get a little bit interesting because the execution order doesn't matter. And it's not the cell order. So in that respect, it is really, really different from a Jupyter notebook, in which if you do things properly and you want to make the notebook reproducible, you have to make sure to rerun it from top to bottom, because the execution order in Jupyter is the cell order. Here, because it's defined by the DAG, the cell order doesn't matter. So this would be a perfectly valid notebook, and you can put the cells however you feel like. So if you have a bunch of definitions that you want to throw at the bottom of your script out of the way, like, you're free to do that. And those two notebooks, which have the same cells but in different orders, are absolutely perfectly equivalent. And so why are they equivalent? Well, that's because this is the DAG that's going on behind it. This cell 0 here is a definition cell. I define this A variable, but this A variable is not used anywhere else. So this is a node all by itself. So definition with no references to it. Now, in cell 1, 2, and 3, I am defining variables that then are used in cell 4. And so cell 4 as references to the definitions in cell 1, 2, and 3. So the execution of the code and what gets rerun when depends on this DAG. So the order of the cells is irrelevant, because the DAG will be the same even if you move the cells around. So it's just a very different philosophy. But because this might be new, there are really cool tools to navigate and understand the data flow. So let me quickly create those cells so that I can show you how you can visualize this little DAG directly in the notebook. So let me actually do it this way, that'll be faster. So I copy this cell, and then this one. Sorry, this is a bit of tedium. I thought of adding cells beforehand, but I wanted to show you how to create a brand new notebook, so that's the trade-off. Plus, the code is not exactly thrilling, as you can tell. I thought I would keep things very basic to show the principles, because obviously the principles are the same when the code gets complicated. So, okay, here are my cells. So I can open what's called the minimap, and the minimap is useful to show the navigation. So this is convenient. I can go back to various cells easily, but also whenever cells have some dependencies, you can see a little graph. And so my list, for instance, you can see that it depends on the variables A1, A2, A3, and A4 that are in those 3 nodes, meaning those 3 cells. If I click on A3, I can see that it is a definition that will be referenced in my list, etc. And if you have things that are a little bit more complicated and the minimap doesn't cut it, there is a more fancy dependency explorer that can show you things in more detail. And if I click here, for instance, I can see the references and definitions pretty nicely explained, and you can explore things and you can visualize them in trees. And although the trees is not very convincing on this picture because I have so many independent nodes that aren't interconnected, because this is not a real script, it's just some explanation. But so this makes it really easy to familiarize yourself with the way things are run under the hood, basically. Now, I mentioned that if you have some very heavy cells, heavy computations in some cells that you don't want to rerun, you can manage what is run when. So on cell change auto run is this automatic rerunning of everything that depends on a modified cell. You can just disable and turn it to lazy, and then if you modify a cell, the dependent cells will not be rerun, but they will be marked as tail so that you can see what's going on. Also, if you open a notebook that already has some content, it will be automatically run as you open it. You can also disable that. So those are settings at the notebook level. And if you want to change them by default, you can go in your user setting and make that the default for any new notebook if you want. But if there is one cell that you want to disable, because like one cell is really heavy, but you don't want to disable the auto run for the whole notebook, you can also go to that particular cell and just disable the reactive execution of that cell, and then that cell will just not run until you reactivate it. So that's something that you might want to do as you work on some section of the notebook, to not rerun the heavy sections until things are ready to be fully run. So that's convenient. Now let's talk about Markdown, because one of the advantages, of course, of notebooks is that you can do some literate programming and embed some text formatted with Markdown in between the code. And on every cell, so first of all, you can, by clicking here, create a new Python cell. By clicking here, create a new Markdown cell. But even if you create a new cell, which by default is a Python cell, you can either use the Ctrl-Shift-M to toggle it into Markdown, or click on this little Markdown symbol here that will turn it into a Markdown cell. And then you can change the F string and row string. Those are Python Python type of strings. The F string is what in a Python syntax you would write with F and then the quotes, and that allows you between curly braces to have a variable that will take its value from the code and be updated as you run your formatted string. And row strings allow to embed some LaTeX inside your Markdown, for instance. So this is how you can have some Markdown cells. So I do have an example of Markdown cell later. I should have put it here. But there are even some more fancy things. They have, so this is Marimo specific. This little syntax with those three /details / and then whatever you want as header and whatever you want in the text, and then the closing three / that exists with details, admonition, or attention, that creates some little boxes. So let me, sorry, my key bindings again. So let me create a new cell and turn it into Markdown. So to do that, this time I'm doing it with the key binding, Ctrl-Shift-M, and then I am pasting this detail one, and that creates a little accordion box that can be open. So you can easily have little things like that in your notebook. You want to see the what the tip looks like. Oh, did I turn it into Markdown? I guess I did not. Yeah, there we go. This is what the tips look like. And of course, all this is customizable because you can add a CSS file. Oops, forgot to turn it into Markdown again. And this is the attention box. If you click on the notebook setting, you can have custom CSS files. So you can customize the display of any of these things if the default is not to your liking. Plots work as you would expect. And here, I don't have the packages, and you will see what I was explaining about dependency not being resolved by default. So I'm going to run this little Plotly Express plot, but I don't have the Plotly package. So I have the little pop-up. Okay, great. But then I have an error message because Pandas is not installed. So it would be nice if Marimo would also automatically install Pandas, but and probably they will implement it, but that's okay. So I'm going back to my terminal and I ran uv add pandas. Oh, okay. So now I can close that. And so now I can rerun it. And now that pandas is there, I have my little Plotly graph. And as you can see, the JavaScript of Plotly works. So there was a question in the chat when just before I started the webinar, can you play with 3D interactive graphs in Marimo? Yes, the JavaScript, which is very often problematic in Jupyter. I mean, I haven't tested Marimo at length, so I don't know whether it always works, but at least in basic cases like Plotly, it does work. The interactivity is maintained. It might break for more fancy plots to be tested, but at least they are trying to implement it. And then you can turn your notebook into an app. So you can run it into a script because it's a Python script. So you can just do Python notebook.py and it's going to run the Python script. But you can turn it into an app by using Marimo run and then your notebook, or if you are in the notebook, by clicking on this little button here to toggle app view. And so the app view will hide the outputs, but will show it will hide the console outputs, but it will show the cell outputs. And so basically it shows the non-Python code, so to speak. Like, I'm not 100% sure, to be honest, when you would want to use the app, except maybe to give presentations. But because they implemented it, there must be some usage for it. I'm not 100% sure where people are using the app, but it's just an option. And you can toggle it back to edit mode. Okay, we are slowly running out of time, so I'll try to pick up a little speed. AI is part of Marimo. So GitHub Copilot, if you enable it in the setting, works for completion with tab, easy. Generating cell with AI can be done if you click here, and then that opens a prompt and you can type things. I'm using Gemini 2.5 Pro because you can have a free API key with that. The results have been a bit hit or miss, but I think the problem probably is Gemini more than anything else. You can also refactor some cells instead of creating a brand new cells. Because if you do this is pretty much vibe coding. You have a prompt, you tell Gemini, okay, write a data frame with polars that would have 3 columns and 2 rows or something. But refactoring is when you already have some code and you would like to edit it. In that case, you go over here, and AI completion opens a little prompt, and here I could say, how could I change my plot? Change the size of this plot. Let's see whether that works. Ah, yes, okay, I need Google Gen AI for this to work, I forgot, right. So it's okay, up, it's easy to install. And so let's, I think maybe rerun it. No, is it thinking? Yes, okay. Well, maybe I'll pass on that. When it works, it proposes a little change on the right, and you can accept it, reject it, make changes to it. But well, okay, let's try to relaunch it now that I've installed the Gen AI thing, because that was probably the problem. So change the size of the plot. Okay, so now it's running. Yeah. So of course it's contacting the server, and because I'm on the Gemini free thing and it's a popular thing, it takes a little time. Of course, it uses the whole notebook as context. So that's also why it takes a little time. Well, it was working a lot faster when I was testing it before. So maybe I will skip on that demo. But then you can also open a chat. So while it's thinking, you have here a little chat with AI here, and you can type things and just chat on the side. And this is just a chat. Or you can really go crazy and generate a whole notebook from scratch with Marimo New. So from the command line, you can, like, this is like really crazy vibe coding. Okay, I'm gonna stop this. I apologize. I don't know why it's not working. It did work in my, oh, and I cannot even stop it. Well, stop. There we go. Well, this was not very convincing, but it did work in my test. So if you want to go really crazy, so of course I have to use UV-Run as always, and then Marimo New, and now I'm asking, create a cool looking 3D plot with matplotlib. And if I run this, oh, well, that was quick. Where did it open? Oh, there we go. A brand new notebook open. Of course, I need to install new things. And there we go. So this did work. This is like pure vibe coding from a prompt in the terminal. I just generated with an LLM a brand new notebook that then, of course, I could edit and tweak and refactor by using the refactoring that I failed to demo for some reason, but that does work. So yeah, so AI is integrated into the tool is the key message. It is 11, so if some of you need to run, feel free. The webinar is being recorded, and we will post the video, and I will try to rush through the end anyway. So we talked about like the general usage of Marimo, but I mentioned in the intro that there are some interactive elements. And so this interactive user interface is actually quite cool. And as soon as you launch a new notebook, the Marimo module gets automatically imported into the notebook. A new cell is created at the top that imports Marimo. So you could just use marimo.ue to use the UE elements that depend on Marimo, but it is nice to create an alias so that you don't have to type the full Marimo name each time. So let me create a new cell. So import Marimo as MO. This is something that people, oh, What's going on here? Ah, okay, I have it here. Okay, my bad, I defined it twice. Yes, and so because you cannot have repeated variables across cells, even having MO imported across cells is an error message. So I don't know why I had it here. I might have passed it twice, but that's what the problem was. Okay, so now that I've imported Marimo as MO, whenever I need something that uses marimo.some method, I can use mo.some method, and the interactive element uses the UI for user interface method. So to create something, an interactive element such as a slider, you use MOUE slider. And there's a bunch of elements that you can create this way. And to display it, you just have to call it at the end of the cell. So make a new cell. In the first line, I define the slider, but if I stop there, it doesn't show. If I want to display it, I call it, and now I have my little slider that goes from 1 to 10. And then if I want, so this is a definition. This slider is a variable. So this is a definition cell, and the value that I set through the slider, the value of this variable, will be an integral part of the Python code, meaning that it will automatically rerun every single cell that depend on this variable slider as I change the value. So if I want to extract the value of a slider, I can then, run in a different cell. Slider.value, and you can see the value is 1, but if I change it here, now it's 3, 4, 5, you can see that the value changes in the cell below as I move the slider. Of course, you can format things a little bit more nicely using, for instance, some F strings. So instead of just calling slider here, I can write some F string, and I'll explain. Well, actually, a way to write some markdown in Python directly without having to go to the markdown type cell is to use the mo.md function and then writing the markdown directly there. And here I'm using an F string. And so if I rerun this now, I have a nicer little format with pick a value here. And similarly, I can format the output a little bit nicer. So if you want to create an app, you would probably want something like that. That looks a little bit nicer. And so now you can see that I have this interactive element. I'm not gonna run through the example due to lack of time, but this is an example with a date selector and the same idea. The little element now is a calendar picker. You can also have a progress bar that looks very much like the TQDM progress bar, but it's very nice. And if you run this code, you can see how it goes. Just, I don't have time to demo it all. But before I let you go, I want to talk a little bit about what's going on under the hood. Because as you define this, like play with this notebook, your notebook.py file, of course, gets updated. So what does it look like? The Jupyter notebook is not something anybody is ever interested in looking into because this JSON nightmare is unreadable. But this is actually quite interesting because it's fairly readable, and I found it very enlightening to see what was going on. So as soon as you create a notebook, this is what gets created. So your cells go here, of course, will be replaced by your cells as you create them, but import Marimo happens automatically. Then you have this little snippet with the version you are currently using. And then this little run app at the end. So now from there, if you create an empty cell, notebook settings. If you edit not your user settings, that go in the TOML file under your config, but if you modify things here, those are settings that are specific to a particular notebook. Those settings automatically get added in here. They go in this Marimo app function here. And now each time you create a new cell, what you have that gets created is actually one of those unnamed def underscore function, so that they don't enter the global environment but remain cell local, get created with an app.cell decorator. So if you create an empty cell, this is what you get, an empty function. And then as you add some element, for instance, in the cell you write this up, those elements get written in your Python file this way. And you can hide the cell. It's something that I haven't shown, but it's something that you can do with over here, hide code, up. And if you do so, hide code equals true gets passed in the decorator, and that's what hides it. Now, when over here, these are definitions. So this is a definition cell. This cell doesn't have any reference to something else. So that's why no argument is passed to this function here. But when you get to the point that you are referencing variables that have been defined in other cells, those references are passed as argument of the function. So if in some early cell I have written x equals 8 and y equals 9, now when in a new cell I run print x, I have in the body of the function print x, but this x that depends on another cell that references from the DAG, it is passed to as an argument to this function definition. And if you have multiple references, of course, they are added here. And for debugging purposes, if you're running into some issues, you can run the modefs and modrefs methods to print the definitions and references of every single cell. So you can run this and see what the refs and defs are for your cell. And now, what about this markdown? I mentioned it a little bit earlier, but when you turn a cell into markdown, what happens is that because markdown depends on Marimo, the Marimo module is imported as a dependency of the cell, and then the markdown code is passed in this marimo.md method, and this is the markdown cell. So if you turn a cell into markdown and then have some markdown with like some heading and some italic and all that, in your Python notebook, this is what it's going to look like. I can show you what that notebook that we've been creating looks like. So let me move it to, let me also make the font bigger. So this is the result of the notebook that you can see here. So this is the notebook we have created. It doesn't have a lot, but this is what it looks like. You can see the path of the Python script at the top. And if we open that script, this is what it looks like. So there is one app config, which is medium, because it is read from my user settings, but I could change it here. By default, it's compact, which is a little bit smaller. And if I do this, now you can see that the medium here has disappeared because it's reverted to the default. And if I let's add a new cell above at the top here, an empty cell. If I go back to my notebook, you can see now this empty cell here got added. And so this is all a Python script. It's easily readable. There's no problem with version control. And yeah, so yeah, this is it.